Yeah, hello everyone. This is Sandana Krishna. Yeah, first of all, welcome you to the first live session on BSc Python. Yeah, yeah, congratulations for everyone for clearing the foundational level and coming to TSA. Thank you for taking the BDC course. Yeah. Okay, the first session is all for the agenda is totally open session. So you can ask whatever the doubt you have. Or we can discuss the week one content. Yeah, I'm here. Yeah, you can.
Sir, am I audible?
Yes, you are audible.
Sir, I wanted to ask just Madhavan sir introduced us to variable assignment that related to, actually we learnt about multiple variable assignment in one line in programming course, but Madhavan sir introduced some tuple element to that. So can you explain that a little bit deeper?
Oh, okay. Okay, that's both are exactly the same. The way it works also exactly the same. Okay, I'll demonstrate with the circuit.
And also, sir, does tuple using tuple, does it bring some advantage or in the technical side of the?
Okay. Yeah. Okay, can you able to see the screen now?
Yes, sir.
Okay. You are introduced that how to assign a tuple, right? How to, that's multiple ways that T equal to tuple. It's one way of assigning. And another way is using a parenthesis. Okay.
Yeah.
Which we are used to. Another way is simply 1, 2. It is also a tuple.
Okay.
Yeah, see, it's a simply a tuple. So what SAR used is SAR simply used a parenthesis before and after. That's all. There is no difference between this.
Actually, sir used like bracket a comma b equal to bracket 1 comma 2, like that.
Yeah. Okay. It's yeah, simply is okay. To swap the variable, we normally use the tuple Python's inline swapping, right? Okay. So
Yeah.
SAR simply did, and how this line works is exactly tuple. And whenever the Python reads, it will a comma b, it will defaultly converts into a tuple only.
Okay.
Yeah, similarly like this one. Then it assigns the b comma a into a tuple, which is a comma b. Chat simply introduced brackets before that, before and after that. That's all. There is no difference with that.
Okay.
You can use brackets or without brackets, it works.
Okay, sir. Thank you. You can take the next question now.
Meher? Yeah, what's your question?
Yes, sir. In this tuple, so that sir said we can't use this method in real life because he gave this water bottle example, if you remember. Like, I didn't get what he meant by that we cannot use this simple technique in Python.
Okay. I didn't get your question entirely.
But we need to use a third variable.
Okay. You are saying you are using, you want to use a third variable?
Yeah, sir did it with using a third variable.
using swapping that variable number values, are you saying? Or
So like he said x equals a, and then exchanged the values, and then the value in a got to the other one. Did you see that lecture?
yeah. Can you say which lecture is it is?
To see. Wait a minute. It's week 2, lecture 1, measuring running time.
Okay, week 2, lecture 1. Okay. Which slide? I mean, can you give us some heading or
Measuring running time.
measuring running time? Okay, sorry. Can you give some any other which is the after that Aadhaar card example or before that? Yeah, measuring running time. I got it. I got it. Yeah. Yeah. I mean, SAR simply explain. You can use way, right? Okay. Can you able to see the screen? See the PDF?
No.
Okay. Okay. Can you able to see it now?
Yes, sir.
Yeah, it is simply SAR explained. You can use the tuple, tuple method to exchange values, or else using a temporary variable.
Okay.
Yeah, just ignore one temporary variable. That's all.
So we can do with any method.
Yeah, anything. Both are fine.
You said that when we check whether n is a prime, then we do not check the magnitude of the number, but the number of digits.
Okay. Okay. You are saying we are not checking the magnitude of number.
Next slide only.
Okay.
Yeah. So in sorry.
Yeah.
Yeah. So it says is n a prime. So like
Yeah.
magnitude of n, because when we check prime, the number of steps it is corresponding.
Okay. Okay. How sir explained this? I mean, in some case, that the variable which is significant is the number of digits are like that. I mean, here the magnitude of n is not a correct measure. Does means number of digits required.
But why? Because when we check whether a number is prime or not, we check from 2 to n in range. We check if it is not divisible by any number between that. So it's a lot of steps. So magnitude of n matters in this, right?
No. Can we say the answer, sir?
Yeah.
Yeah. Actually, we don't check up to the n. We can
Yeah.
we can check up to the square root of n. So it's enough.
Yeah.
Using that modulo operation. That's
okay. In n is n a prime. The magnitude of n is not a correct measure because you need at least like a n into n minus 1 comparison you have to make in a naive way.
so this is also a method, but this is not efficient, right?
Sorry, it is not.
magnitude of n is also a method, but it is not efficient, so we do it by digit.
I mean, we cannot totally simply say magnitude of n is the, it is not a correct measure.
Why?
Okay, let's say in a naive prime algorithm, we'll go for n. For each of the, the final one, you will get to compare with the up to n minus 1 in mod of, in a naive way. Whether it's divided by n minus 1. Now, n minus 1 is not even a big thing. You can go up to, like the n by 2. It will give the overall complexity, it comes to n square.
So
Order of n square. Yeah.
n square is not efficient, so it's not a correct measure, right?
Yeah. There are some cases we can't avoid big of n square, but in some cases we can. Okay. This here the one conversion. That Aadhaar card example, right? Okay, I think it is in week 1. Okay. Yeah. In this Aadhaar card example, a naive algorithm works for n square, but it can be simplified to n log n.
So he just said that n square is not efficient. Yeah.
Yes. N square is not an efficient one.
So okay. And so he explained basic operations, but why didn't he include recursion in the list? He said that you can have if, while, assignment statements.
Okay. Recursion and iteration is just a way of implementation. That's it.
But it increases time.
Yeah. The way you find the time complexity in recursion is different, right? In a iterative fashion, it is straightforward.
I didn't get you. Like, what
Okay.
did he mean by basic operations? Where are they used?
Okay. Sir told most about the unwinding that recursive procedure and getting the time complexity from that recursive function.
Sir, can I say something?
Yeah.
So I haven't watched this 2.1, but what I think according to the input size heading that's there in the top, the one in which ma'am asked that input size is not dependent on magnitude, but the number of digits. The way I think it to be, suppose you are entering a number and you want to know what size it is consuming inside the memory of a computer. So instead of, suppose we are entering a number 34, and another thing, we are entering a number 33.6. So it might happen that 34 is greater in magnitude, but the amount of digits is 33.6 that is consuming is greater than the 34.
Okay.
So he might be saying the input size in terms of number of digits, that is each digits take some 4 or 8 bytes. I don't remember exactly. So if the number of digits increases, I think the input size, the amount that it is consuming in the memory also increases. It not just depend on the magnitude of number is what I think.
Yeah, that's one way I agree. But in default, the Python works in a different way, and the other program works in a different way, right? If you are representing a float value, if it's a 1.0 or 1.21 something number of digits, it takes both takes the same time, same space. If you are using a float data type.
Okay, sir.
Yeah, with respect to float data type, it's okay. If you are representing 1.0 in a float data type, and simply 1 in an integer, that size will be varied.
But isn't this is true when suppose we are taking an integer, suppose we are taking an integer 32 and another we are taking same value, but we are putting a 0 before it, so 032. Both are integers.
Okay. Yeah, both are same.
But I think the memory
Okay,
that will be
that
consumed.
okay, that I agree, but it's totally based on the algorithm what you are using. You can find the GCD, which is just that I mean that number of times it have to run is based on the number of digits you have. That's the optimized GCD algorithm. Maybe you are aware of that, or else it will be introduced. Yeah,
Agreed, sir.
yeah.
Thanks.
I mean it's totally based on the algorithm. Okay.
Yes, sir. Thank you, sir.
Yeah. Okay. Anything from week one? It's this live session is more supposed to be about the Python, whatever the requirements in Python or Python doubts clearing.
Hello, sir.
Yeah.
Yeah, sir. Me here again. I wanted to ask, sir. I actually timed all these GCD methods that were taught and using the timer class that sir showed.
Okay.
Sir, in that I used this 2 comma 9999 example in the slides, sir, and it is I found that the list method and the MCRF methods are actually faster than Euclid's algorithm with respect to this example. So, sir, is it related to recursion? Because of recursion, is it getting slow or?
Yeah, in Python, the recursion is costly compared to iteration. That I agree. Yeah, if you are using a recursion, I mean, with respect to Python, yeah, if you are
Yeah.
using a recursion, it's quite costly. It will take some more time. Also, you have some limit to a recursion.
Yeah,
Yeah.
sir talked about the recursion limit in the last lecture. That is okay, but actually the Euclid's method gets away with the recursion limit, right?
Yeah.
So in that only I was wondering why is Euclid's algorithms slower than the list method?
Okay, can you refer to which lecture you are referring?
No, this wasn't in any lectures. I actually tried it with this collab only, and the can I share the
Yeah, sure.
collab link so you can also try it out?
Yeah, please, you can share your screen. We'll check on the result.
Wait, sir, I will try.
I think, are you seeing the share button?
Yeah, wait, sir, I will try. Are you able to see, sir?
Yeah.
So, sir, see, I am running this Euclid's algorithm.
Okay.
And now this program, you understand, right? This 2,9999.
Yeah.
I run this and now it's showing 0.0018. Okay, the first time I run it again and it's this one. But sometimes, sir, it shows this timing, and for list method it's coming less. So I don't know if it's down to the variability or what. Let me try it again.
Yeah, I understand. This timing will, you have to work on multiple times, and sometimes it will vary. Also, one more thing, the better way of getting the time right, you have to run it for 10 times and taking the average.
Okay.
Yeah, that's a bit, because based on some withholding process or anything, it will take some more plus or minus some time. Yeah.
Okay. Yeah,
Also,
sir.
always go for any very larger list and make your time.
Sir, yeah, what do you mean by that?
I mean, always go for if you are timing sorting method or searching method, right? You always use a bigger list as much as possible within a reasonable time. I mean, use a big list for checking two things.
Okay, okay. So, sir, how will that translate into this example?
Okay. I mean, just give some more big value.
Okay, sir, actually, if I take like this example, I think it will run pretty fast. I had 2, 3, 2, 5, 2, 3, 2, 6. And now, sir, let's compare it to the list method. Okay, wait, we should note down. Yeah, sir, now we can see that it's less, but
Yeah,
according
also,
to the,
okay, yeah, I get it. I mean, whatever you do, right? Make an
Mhm.
average run for both the method and compare your answer.
Okay, okay. So, sir, if we put a loop here, and then can you suggest any code to so that the value
Okay,
that comes
there
over
is
here?
actually, if you are using Iron Python notebook, right? Colab, there is a called modulo time it.
What, sir? Sir,
Modulo, yeah,
can you
yeah,
share your screen and then show it?
yeah. Okay, I'll share that. Modulo time it. Yeah, 1 minute, I'll share my screen. Okay, I mean, I'm simply open the Iron Python console. If you are using modulo time it will time it for the whatever the operation you are doing. Right? It will take 2.42
Okay.
milliseconds with respect to certainty per loop.
Okay, okay. So we have to write modulo time it before the operation,
Yes.
and we have to remove the start and stop thing.
Yeah, it is one way. I mean, sometimes when you are doing a very large list operation, modulo time it's not a better choice.
Okay, okay.
Yeah, I mean, it's a
So
one thing, but it has some limitation. When you are using I mean, simply running a function, it works. I mean, I'm saying it's one of the way.
okay, okay.
When
So,
you
sir,
are using a standard time, it's a very standard way that also works. That's very straightforward.
okay, okay. So, sir, if anybody else doesn't have a more relevant question, can we try this modulo time it with
Yeah,
just 22999 example? I will share my screen again.
yeah. We'll do that once everyone's query was answered. Okay.
Yeah, yeah,
Yeah,
sure,
I'll
sir.
just give an example. Just I simply wrote a function to append a list and do nothing with that. Okay. It will run and for certain loop. I mean, the number of loops it is totally decided by itself only. Yeah.
Okay, okay. Yes, sir, I got it. I will surely try this modulo time it method, and
Yeah, it is not. Yeah, it's not by recommending or anything. It's one way you can use the standard time also. That's not so works.
okay, okay. And sir, we do not need to import any library to use this, right?
Yeah, you don't need, but it works only on Iron Python notebook. I mean, it only works on Colab or Iron Python console. It won't work on that modular time. It won't work on regular Python.
Okay, so it won't work on Spider and anything
It
like
will
that.
work on Spider, but it won't work on I mean, regular Python, right?
Okay, okay.
Yeah. If you are using simply Python console, it won't work. In that
Okay,
case,
okay.
I better use the time function. That also works.
Okay, okay. Thank you, sir. So we will revisit this in the end. You can go to next question.
So you were explaining basic operations.
Sorry?
So you were explaining basic operations. It's to
Basic operation with respect to?
in time complexity.
Okay. Okay, you want to explain how basic operations and time complexity.
Yeah.
Okay. Okay, can you say where you want any specify any lectures? Then I'll resolve this.
Lecture.
Yeah, any specific lectures which you have? If you have not understood or
I didn't understand what he.
okay, okay. I mean the basic time complexity. Okay, 1 minute. Just hold on for a minute. I'll take my writing. Yeah, can you able to see the screen?
Yes, sir.
Okay, time complexity is nothing but okay, how much time it will require. I mean, it's not an exact absolute time. Let's say if you are running just a for loop for 100 times, okay, within a nested for loop, you're running for 100 times, you simply know how much time it will take. Okay, you can say it is the standard value. Let's say you are comparing each. Okay, you got it right. Now you got now how many times that entire program will run.
So when he writes running time, like this,
Yeah. Okay, I'll give more precise answer.
no, so I get it, but it doesn't tell you time in seconds. It tells you number of
No,
steps.
no, it won't give you a time. It won't give you any seconds, but it will give some values which is significant. Let's say if you are running a very practical thing. Yeah, if you are running a list for 10, okay, it have 10 elements. You are simply searching element by element at max. The worst case, you are going from first to last. In the worst case, if the element you are searching is in the last element, then it will take like a, I mean, 10 times 10 times of second, some second. Okay. Let's say you are taking operation like 1 second for searching one element. Let's say it will take 10 seconds. It's just a value which is based, the time is based on that value. That will different for different computers.
So that is not number of steps in square.
Yeah. That's the thing. Let's say you just say in the you are comparing each each value with each other value. Okay. Do something. I mean, you can make an assumption that, let's say I gave you a number. I mean, I gave you a list. Let's say my computer was a slow computer. It's not works on a very old processor. Then I'm taking this time. It is taking for it's 100 of elements. It is taking some 5 seconds. Okay. Let's say I'm giving the same program to your computer, your PC. Then you're running on a very new processor. Then it is taking only 1 second. Okay, then I'm giving another list which is based, let's say this compare the same program. Okay. It is n square, order of n square. Then I am saying giving a list of 1000 elements. It is taking, that will be a n square times that value which is comparable. Did you get the point?
Yeah, like
It is not the exact time or anything. Let's say your computer will, in a simplified thing, your computer will take 1 microsecond for one operation, simple operation. Mine will take a 0.5 microseconds or 2 microseconds, whatever. That value will be proportional.
okay, so that's proportional to it.
Yeah. Whatever runs, which is getting late on my computer, irrespective of the processor time, it will be same level of, I mean, time it will take on your computer as well. It will be proportionate.
But sir said that irrespective of hardware, Python takes 10
It's,
hours.
yeah, it's different. Yeah, that's what I'm saying.
So it doesn't change time.
Yeah. I mean, it with respect to the order, it will don't change. If I same time which is taking, it's some proportion.
And so I have confusion. I understand the concept, but I have confusion between these terminologies. So when we compare two functions, so introduce big O and upper bound. So what's the difference between these two terms, big O and upper bound?
Okay, big O is just almost the same. It is like a big O is the worst case situation. Okay, I mean, let's in a simpler case. There is a list with 100 elements. I am searching an element which is 1900. Okay, 100 which I am searching. I'm starting from the beginning. Then the name search, I have to go one by one. So what is the worst case? The worst case will be getting the whatever the element which I am searching, which happens at the last with respect to the nice search. Then that is the big O of, then this will be considered as a big O of n.
In, when it comes to two functions, that fn is a big O of g, what does it mean?
Okay. Okay. Here, I can say G is a big O of f of n. That how I am saying is big O, if you plot a graph, I mean just a 3n will be a simple line. It will be a parabola. After a certain point, the value of g for some x, let's say x prime, the value of g G is always greater than value of X. That's why G is called the upper bound of F, or else the big O of F.
So G is both upper bound and big O.
Yeah.
It's the same terminology.
Yeah, it's some way of convention. That's it.
But this is not worst case when we compare two.
No, that is different. You are comparing two different functions. Okay.
Changes in this, right?
Yeah. I mean, the way it was defined mathematically, it's the satisfied. Yeah.
So it's the function which grows when the n is large, which is.
Yeah. I mean, whatever say, right? It's a n cube is the upper bound of f. N cube is the upper bound of f. Let's say h, which is n cube. Okay, which is the upper bound of f. But let's say k, which is 2n plus 1. But I cannot say k is the upper bound of f. If you visualize using a graph, right, it is k, it is f. It never crosses. I mean, it never cross. It never be a higher value than f for after a certain point. It always be lower. Let's say we can say k is equal to 0, but at some point it was lower. But that's not matter. After a certain point, the value of k is always lesser than the value of f.
Yes, sir. Okay.
You got the point, right? It is called asymptotic complexity.
Yeah.
Yeah.
And so, what is the meaning of order of magnitude? This term I didn't get.
Okay, that I mean, okay, in a visual way, I can write the same for the same graph. It is 2n, it is 3n, so okay. It is always great. The value of f is always greater than the value of k. Okay, you understand, right? Then you can write in that way. F is the order of k.
So
Upper bound of k. Upper bound in the sense the value of k never touches the f.
What is order of magnitude in this? Is it k?
Order of magnitude is like a let's say okay, for k you can say I can say order of upper bound of n.
So it's the value basically that is.
Yeah. I mean, some constant you are multiplying by it, some constant c, then it becomes greater. Let's say 2n, it becomes some constant from here. It can be 3 or whatever it wants.
But in his.
Then it should be maintained. I mean, it should be maintained as a like it should be always greater than. I mean, whatever the function which is okay.
So n is the order of magnitude here, right?
Yeah.
Okay. And so last question.
Yeah.
Like in programming assignments and these tests, so how is it going to be? Like, will they test like how efficient algorithm we write, or just?
Absolutely. Yeah. I mean, maybe in the first week there won't be any efficient algorithm. We are not asking about that. But surely, if you're going week by week, right, you always have to write a efficient algorithm. There will be a timeout or like that. If you are not giving an efficient algorithm, it will be considered as a failed test case.
So how can we prepare for that?
I mean, it's totally based. Sorry, how can you?
How can we prepare for these kind of?
Those are always based on the lecture videos.
Okay.
I mean, the best advice I'll give is always care about the asymptotic complexity.
Okay. Thank you, sir.
Yeah, the way I'm saying is, let's say there will be a algorithm which is like simply explained, which takes some time with respect to n plus 1. Okay. G of n is simply n square. Both f and g are doing the same action. Let's assume an imaginary sorting example. Let's say sorting, but there is no sorting based on order of n. But yeah, there is something. But yeah, let's say it is f of n takes 10n plus 1. It's order based on time. Another one is taking n square. Okay. Let's say assume I am giving n is the number of elements in the list. Length of list. I'm giving only one value. I'll go through mathematically. Then f of 1 will take 11, but g of 1 takes simply 1. You may say why it is a reason we are very much implementing a asymptotic complexity.
After a constant.
Yeah. After a certain time, let's say f of 4 40 plus 1, then g of 4 will 16. I mean, after a certain time, it will cross that line. Until then, it was fine. I mean, you can use for us in some case for a very small sorting request, you can say f is fine. But when you are dealing with a very in a small case, you can say g is fine. But when you are dealing with a very large list, f is the very efficient algorithm here. Yeah, keep this in your mind. I mean, whenever you are watching lecture, always find what is the complexity of this algorithm compared to the another algorithm, which provides the same action, which is doing the same action.
We will be given a range of till 1 million or something. We'll check against that big values only, right?
Yeah, we will do that. I mean, we can say you will have maybe in the test case you will have that input size will be 0 to 10 power 7 or like that. I mean, we will give that. But you never know why your why your test case was failed in the private test case. We simply know 4 out of 7 was fast or like that. So you have to improve on it. Yeah.
Okay, sir.
So in this whole course, it is totally in Python. You can write some code which delivers the output, then it's fine. There is no problem. Then you will get all the marks. In PDSA, you have to give a very efficient code as well.
Right, sir.
Okay. Anyone else? Yeah, Mihir.
Sir, can you touch upon little bit on why Python is 10 times slower than other languages?
But I'm not that much. I didn't know that background of Python, but I will say Python is based on C only. It is a layer over the C.
Okay.
So one more
beneath,
thing, Python is a scripting language as well. So you are not compiling. You never know what is going to come next, right?
okay. So, sir, there is a possibility that in real life working situations, we will have to transfer the language of the knowledge that we have gained in this algorithms to some other faster language.
Yeah, when you go to the Java course, right, you will understand that.
Okay.
No, so we can say that in the Python there is also one Python is there.
Yeah,
So
Python is there. You can use C as running.
yeah,
Yeah.
Python is like a speed like a C.
Yeah.
Okay, so sir, Python will have the same speed as C++.
Yes, almost.
Yeah, Python allows you to run that C and Fortran. Fortran is much faster when you are doing the numerical computing, better than C. I'm not saying that operation, the numerical computing, that's why Fortran is considered as a, scientific language or like that. That not much used in a commercial activity like that. It's mainly used for scientific computing.
Okay.
Yeah.
Yeah, sir.
Python supports Fortran as well.
Yeah, sir. It was actually quite surprising to learn that older languages are faster than newer languages.
Yeah, that I agree. But in a time when you are doing a small operations, right, it doesn't matter.
Okay.
Whether you are doing in 0.001 second or 0.01 second, it doesn't matter. For
Yeah, sir,
our,
but
but when we are doing a very large list or very complex thing, then only it matters.
yeah. That Madhavan sir was talking about that Aadhaar and SIM card operation. I think in that situation, this 10 times factor might matter a lot, right?
Yes, absolutely. That's why most of the video games, all those things, right? Those
Yeah.
backends are always work on a C only.
Okay.
Yeah, in that case, you have to process lots of things. You are not giving a 10 times faster. If you are using Python, it will be 10 times slower. How you are playing a game which is 10 times slower than you are playing now.
Yeah, sir. So on the same hardware, C++ will run way faster than Python.
Yeah.
Okay. Thank you, sir. I think Python is way better in terms of speed of grasping and learning and all that. And then during application, we can shift that knowledge to another language.
Yeah, all that matters is what is the algorithm, how you are implementing. That's
Yes.
yeah. Language doesn't matter. It's just a symbol. In a overnight, you can get the symbol and write it in the same algorithm. You can write it in different language. That's it. Yeah. All that matters is what you are learning in PDSA. It's not. We are just using a Python as a tool. That's it.
Yeah, sir.
Python have some very much hands-on feature that I also agree, but just focus more on the algorithm. That's
yeah, sir. And one more doubt that just came up. I was thinking while watching Madhavan sir's lecture, sir. In some codes, it turned out that the more efficient code involves importing some library. So does importing a library add to any load to the system or anything like that?
not much. I say there won't be a big. Importing a library like that. If let's say you are importing a library, it contains 1,000 lines of code. That simply adds. Unless you are running that, that won't be a much. It will take some memory. That's all.
Okay.
Yeah, because in Python, right, when you are writing a function, if you are going through it, it simply notes there is a function. Unless you are calling that function, some error won't be, you won't know some error was there until you call that function. It will check for the syntax only.
Okay. So does it relate, what you just said, does it relate to what Madhavan sir said in the initial lectures, how errors are inherited backwards, something like that?
Yeah, that also, that will based on which function calls which function method.
Okay. So if it's like that, if one function doesn't deal with that error, it just
that
passes.
will be backtracked. Yeah, taken into previous and It's a
Okay.
yeah. If you go on line by J, let's say k is a finite function, that error will be backed. In some way, you are preventing and you are using an exception statement. Let's say in Hutch have a triaxle that will be captured there.
Yeah.
That's what Sir explained.
Mm-hmm.
What I said is, let's say you defined a function. Yeah, you wrote something. Unless until you're calling that function, the Python won't execute all those things. It simply says there is a function named f. It takes this parameter and all those necessary things. It will never go line by line and evaluate those things. It will go and check for the syntax things, but not everything.
Okay. So even if we import a whole library and we use just one function from that,
Yeah,
it won't matter.
yeah, that won't matter much.
Okay. Yeah, sir, I got it. Thank you.
Okay. Anything else? Anyone? Have everyone watched week 1 lectures entirely? Yeah, Kumar.
Yes, sir. One thing, a general question I want to ask that in the week 1, we are getting only assignment or the PPA or GRPA. We'll get the something activity question or practice.
No, because it is a standard course also. There won't be any activity questions like Python or C++.
Or some extra practice question paper.
Yeah, you can. I mean, yeah, it is a standard course, so you can refer the books and you can get lots of practice question from. I mean, you have lots of sources. So you have to go through. It is it is a diploma course. So you have to, if you see the number of questions in practice and the number of questions in graded, right? The number of questions in practice always less.
Okay, but DBMS and the web application, all we have a activity question after each lecture.
Okay, maybe I'm not sure about other question, but in PDSA it's a thing we are following. There is no activity question. You can
there is no big the question like that subjective question type of thing.
No.
So we have to find it outside myself.
Yeah. You can refer some other books. Or better you go for some websites that will give you some programming examples for which uses the algorithms and data structures.
But sir, I found that personally that the question you provide is that has more quality than other which we find outside, and it's also very time consuming because that the quality of the question we find that it's very hard to find outside.
Yeah.
So whenever you give that question, so at same place, and we find that very interesting. Actually question finding more powerful than theory sometimes.
Yeah, I agree, because creating that much quality questions is not easy, because in PDSA there is not much freedom like Python. Python, you have a very large freedom. You can ask anything about, simply you have to solve the problem. But here we have to write an efficient program. That question have to make some sense. After solving that question, you have to learn something from solving that. Yeah, Python is just an implementation, just introduction to the. You have to hand-on use of the Python. You have some logic in it. Yeah.
But sir, book outside I have seen that if after solving the 10 question we get something 2 question is very interesting or something. Otherwise here in that if you provide that question, all question makes some sense, and to develop something understanding through the question.
Okay. So, I agree.
Please suggest please make some question and provide us, or select some question from some book and selective question, and also you can provide us in that way also.
Okay.
At one place together.
Okay, we'll try. What you suggested, right? From the books we have referred, that we can do something.
Yeah, it means you know that. So in select after some 4 or 5 books, you can select some good question and for us, which is the beneficial, and which can be through that question we can understand the algorithm in better
Yeah,
way,
agree.
in the application way.
Yeah, I'll take your, I mean, it's very good point, and we'll
Yeah.
take it into consideration and pass it to others as respect.
Yes. Okay, sir. Thanks. And one more question, sir.
Yeah.
Is that any way to find some module or something is existing? Who can say us that if we run some bunch of the program, so how many steps it took instead of that manually mathematically we count that many
Yeah.
steps.
Yeah,
So is
I heard about, I mean, previously I heard about some module or like that, but so far I am not, I never hands-on or anything. But if I know, I will let others in a forum or live session. Surely.
okay.
But for now, time is the only tool we have.
I feel the time is relatively more about the relative thing. It
Yeah.
depends machine to machine.
Yeah.
But the steps is universal. If one steps is
But
it's independent of
it's
that.
also depends on the process load and everything, right? Yeah, I
Which one
agree.
is
I agree. That's it. That step is like a whatever function I wrote, right? The time complexity function. It's like that. Yeah.
yes.
Yeah. That's that same time complexity function multiplied from some constant factor. That's all.
Correct.
Yeah. I mean, but I mean, those won't be yeah big significant amount when you are dealing with a very large data. Yeah,
Yes.
when you are, I mean, you are executing some operations, right? That that operations and time, there won't be much significant difference between those when you are dealing with like a, lakhs of millions of data.
Yes, and sometimes we lost in that some algorithm, and actually it's take the so much time more than minutes. So we just before that running, we want to know actually how much actual steps is there, actually how much is there, not in the form of the time complexity, but in the form of some other calculation. Is that this type of model? Then it will be better.
Okay.
Suppose 4 program we have written, easily we can know that this is going to exactly that much steps, exactly that much steps.
Okay. Yeah, I heard about that some of library which do some manually do those operation, but if I'll search for those and I'll let you others in discourse.
Okay, sir.
Yeah.
Thanks.
But I'm not sure whether it's true or no. But yeah, if I found out, I'll surely let others know.
Otherwise, we can do one thing, no, sir. After writing the program, after each programming, I can initialize something counter, and after each line, I can increase the counter. At the end, I can see the
Yeah,
counter.
that I agree. But if you are using Python, people may write in different ways, right? Yeah, if you are using very I mean, simply let's say, okay, I used a max function of some
Mhm.
list. Okay, if
Correct.
you come up
Module.
with a single line, it is not a single line because let's say it have n elements. It is of order of n. Then you have to increase by n, that counter by n.
Okay. So you are telling that it's internally will take n steps.
Yeah.
But one thing, sir, same question like that someone asked on the discourse,
Yeah.
but
I also then only I get this example easily.
ma'am told that someone told that no, it will take only constant time.
Yeah. Okay, I'm not sure about the constant time for max function for a quick
No,
list.
not max, but it was the split. Split also internally take n times, no?
Okay, that I'm not aware of that. I mean, I'm not know how it works in Python.
I,
How much?
I I will send you, sir, that this is that question.
Okay. Yeah, I saw the question on discourse. Yeah, but
Yes. So that's why one answer was there, n is the time complexity is one n square. But Omkar sir told that its time complexity is n times. So it's the little bit confusing. Practically, I think it should take n square only.
okay, Okay, I mean, simply
Okay.
just
Okay.
if you want to convince yourself, just take a large list and do the operation.
Okay. So checking for myself.
Yeah, I mean that it is the one way that you can assure who is the wrong or in some case. Yeah,
I got it.
yeah. I mean, it is the one way you are validating yourself. Yeah, okay.
So at the end, the time complexity is only, I am sure, when I'm writing the pure code in the any language. If I'm using the module, I have to consider that module thing also.
Yeah.
The module time complexity, internal time complexity inside
Yeah.
also.
Yes.
Okay. Okay.
Yes, Sandeep.
Hi, sir.
Yeah.
Actually, I have a couple of questions and one feedback that I have to give.
Okay.
I'll start with the feedback. I have noticed in the practice assignment and graded assignment, there is some inconsistency in the variables that I have to work with. Like, for example, in the question where they ask to form a class of triangles,
Okay.
in the question statement, it asks to return a value called acute, which starts with a small a.
Okay.
But it doesn't match with the answer if I don't put it capital A. So there are some inconsistencies like that I have noticed. That is the feedback.
Okay.
Please look into it. And I have a couple of questions. It is from week 2. I'm sorry about this because the next week I'll have evening shift. I won't be able to, won't have any opportunity to ask this question. So if no one has any other questions, you can answer these things. Sir has mentioned about 3 notations: the big O, the big omega, and the theta.
Yeah.
Can you explain the other 2, which is not part of the course, I understand, but I always struggle to understand these 2, the small o and the small omega. This is the first question. If you answer this one, then I will move on to the next one.
Okay. Yeah. Okay, I'll explain with that same lecture slides as well. I hope it was a lecture 2, right?
Yeah, correct, sir.
Yeah. Can you able to see the screen?
Yes, sir.
Okay. Okay. Whatever you may aware of the worst case, that is we mentioned as a big O of notation. Okay.
Yes.
Let's say some function which is let's say it is f, which is always lesser than the function which is g. Then we can say f is a omega of g. It is just a opposite to, I mean, just an inverse for a big O notation. Okay, let's say G is the big O of F. It is everyone understood, right? This point. It is the big O of G, big O of F as well. But if you are writing in the opposite way, that F is the lower bound of G. G is the lower bound of H. After crossing some point, G will be always higher than the F. Okay, then you can say, I take this point. So G will be always lesser than. Then I can say it is the lower bound of H. At the same time, if I take the same point here, it always, the value of G will be always higher than F. So we can say G is the upper bound of F. Does everyone was clear about big O and omega? Okay, then I will move to some other, that is theta. Which provides this is some function of like some order of n. Let's say. Then that can provide a function that it will provide both lower bound as well as upper bound. Okay, then order of n, some order of n function. If I say that theta should be, I can make it into 3n, 3n plus 2 or something. Then it will serve as a upper bound always. After certain crossing some point, it will always be a upper bound. If I make this as a simply n plus 1, it always serves as a lower bound. This kind of function is called that theta. We will represent using theta. It will be generally we mention it as a order of n. Something clear? Have you got clear? Am I audible?
Yes, sir.
Okay. Sandeep, are you clear? Is your doubt clear?
Yes, sir, clear thus far, but I asked about small o and small omega, which is not primarily covered in the lectures. If you can answer that. But I find them in the wild, so I thought I would ask you.
Okay, I am not sure about those things. I mean, maybe I am not aware of that. Yeah, it is, at least these are the things I'm aware. Maybe you can ask more on the discourse and I will get back to
Sure, sir. Sure. Can I ask the next question?
Yeah, sure.
This is about the selection sort algorithm. I observed that Professor Madhavan was adding the list, adding the minimum term at the front of a list,
Okay.
and progressively it sorted the list. So I wanted to ask a question regarding what you have an elementary operation, right? If you add something at the end of the list and if you add something at the front of the list, does it take a same amount of time? Does it take same amount of effort from the processor, or is it something different?
Okay, yeah. Okay. That's okay. That is a very good question. It depends on the which data structure you are using. Let's say if we are using a Python, let's say you are using Python list, which is already initialized. Okay. Then
okay, the list already has some elements in it. So what will be more beneficial for me, adding at the end of the list or at the front of the list?
Both are same. Let's say if you are using Python list, okay. In Python list, it is using array type data structure only. It's behave like array. So if you are started using a front or a back, it will work on the same. There won't be any much difference.
But if I add something at the front of the list, it necessarily means that I have to move all the other elements, shift all the other elements towards right by one, and the index will change for all the other elements. None of that will happen if I add something at the end.
How can you say the same thing will happen? Let's say
suppose there are 4 elements in the list.
Yeah, if you are adding
suppose there are four elements in the list.
Yeah, you have to shift all the element by left, right?
Suppose there are 4 elements in the list, indexed from 0 to 3, and if I add something, one more element, it will be indexed. It will have a new index 4, L of 4.
Let's say,
but if I add some.
Okay, let's consider this case. Okay, you simply want to you are in the case of ascending, you are searching from here last to, and you are finding the minimum one and the greater one. You are making a
no sir, this is not the question I asked. My question was, I understand the logic behind the algorithm.
Okay, yeah.
I was asking specifically about if I want to add, the question is from selection sort. The question has nothing to do with selection sort. This is something I observed during the selection sort algorithm. It's about adding an element to a list. Yeah. If I add an element to a list which already has some items, there are 2 options. I can add it at the front. I can add it at the end.
Yeah, you can go start from the
which takes less amount of time. Which takes less amount of time and effort from the operating system, I think.
Yeah, there is okay. I'll say both will take the same time. There is not much of significant time difference between 2. There won't be any. Yeah, you can.
The list is pretty large.
Yeah, it will take the same time. If you it depends on the data structure. That's it's an array type data structure, right? It will take the same time. There won't be any time difference. But if it's a kind of a linked list, what you learned in CT, right? You have to go one by one. Then if you are using that kind of data structure, that will take lots of time.
But in Python, the list is implemented as an array, right? It's not
in Python, it works. It is implemented like a. It is like an optimized way of array data structure.
The logic behind my question was, if I add something at the front, then essentially I have to move all the I have to change the index of all the elements by 1. But if I add something in the end, the index of the existing elements won't change, and a new index will simply be.
I hope that selection sort simply swaps the value, right? Like insertion sort only inserts the element here.
No, sir was going from front. Sir was going from the front of the list to the end of the list, and whatever the minimum item, he was adding it at the front. If I do the opposite one, if I take the max element, if I find the max element and concatenate in the end, and in the next run, I only look at the list apart from the last element.
Okay. There is one more thing. Okay, as the algorithm SAR used, right? Okay, I'll share with that. Okay, SAR here not changing any position or like that. SAR is simply exchanging the value. Okay, in that case, we are not shifting any elements, so that's not a problem. So whatever you go from left to right or right to left, everything works the same. There won't be any significant difference. So we are not moving any elements. In the case of insertion sort, we have to move, but in a selection sort, we are not moving. But the worst case thing is selection sort is always a order of n square.
Thank you, sir. I think that answers my question. Yeah, thank you. Thank you.
Okay. Anything else? Others? Yes, Mikhail.
Hello, sir. Just to build upon what Mr. Kumar asked, sir, can you link or tell any resources where we can find non-trivial solutions to some common problems?
Okay. Okay, we'll search on that and we'll post it on discourse. Surely.
Okay. Thank you, sir.
Okay. Just a general question. Have everyone gone through the lectures of week 1? Or else most of you are skipping lectures in Python or hear the name Python? Yeah. Has everyone gone through the lectures of week 1? Yes. Thank you. Yeah. I mean, that won't be a case, I think, from week 2 onwards. Even if you skip week 1, we can. Yeah, Pratodeep.
Yeah, sir. I wanted to point out something since nobody else is asking a question for now.
Okay.
The course portal, in the course portal, there is some issue with the font size of the practice assignments and the graded assignments, the graded programming and the practice programming assignments. Sir, can you open one of those pages?
Okay, sure.
I mean, it's too big, sir. Even with the course outline collapse, we have to manually zoom out to read the whole question.
This one, right?
Yeah, only PPA 1 is okay, but after that,
yeah, you have to collapse it. Yeah, because it is implemented in the way that.
Sir, even after collapsing, you have to zoom out, sir. Like the end of the sentence is out of the page, sir.
Yeah, actually, we are trying some fix here. We are trying to implement everything within a simply text like PPA1. Okay. Yeah, we are trying that, but currently it is the thing we have to bear it. If possible,
Okay, so it will be fixed. It will be fixed, right?
Yeah, it will be fixed. Yeah.
Okay, sir. Thank you.
Actually, sir, it is that not a text. It is the some picture. So for time being, you can do one thing: go in the inspect element and open this picture in the outside of window. So it will be the fine.
Yeah. Yeah. I mean, yeah, you can simply right click and save the image. Etc. Yeah, you can save the images. Yeah, that's not work, but there is no, and currently there is no fix.
Like I'm
but
sending
we are expecting a fix to this.
I sent the link. Once you click this link, then it will open the complete picture.
Yeah. That's the I mean where the
For reading,
yeah.
Yes.
Yeah, that's the one thing. Yeah, simplest solution is save images. Save images.
Or we can open it in new tab, the first option.
Yeah.
Yes.
Yeah, open image in a new tab. That works better. I mean, we are expecting a fix. We'll try to fix this as much as possible.
I just wanted to point this out so that like you can have it in your attention. I thought no, the course support team didn't know about this yet.
Okay. Yeah, sure. Actually, we know that we are expecting a fix. Sir. Yeah,
okay, sir. Okay. Thank you, sir.
Yeah. Okay. One thing you have pointed out in the same question, right? Circuit with A, capital A. Okay. this one. Okay, thank you for noting the tool. We'll do what we are doing from here. Okay, anything else? Any other questions regarding Python or regarding week 1? Okay, just a heads up. Just be not I am expecting a much proficient. Just be familiar with the classes and object as well. So it will be, there is not much, this course is not relevant to much of a object-oriented programming implementation.
Sir, can you repeat what you said from the beginning?
Yeah.
I kind of missed your first words.
Yeah, just a heads up for you. I mean, how to use those classes and objects to implement the algorithm. Because in some algorithms, I mean, in some programming assignments, you have to do the things using the class only, class and object in operating object-oriented programming manner. So it is just a way of implementing. And just a heads up for you. Just brush up your knowledge in Python. And Python is just a tool. We are not looking anything, not going deeper in Python. It's just we are in way of implementing the algorithm using a language. Okay, have anyone have completed the grader and practice both? Just give a thumbs up if someone did both, completed both. Okay, then I have not seeing any chances, so Erin is going through it. Okay. Okay, anything else you want me to explain or anything to get clarified?
Hello, sir.
Yeah.
So I just joined a couple of minutes ago. Actually, I was busy in a meeting. I just want to ask, what should be the approach to learn this subject? Should we be making notes or it's completely programming based?
In both. I mean,
okay.
Yeah, you may know how the grading works. That's different, but you will have both objective questions as well as the programming questions. I mean, in the end, you are writing your own program.
Right.
Yeah, your way of in a program, there is lots of open ended there. So those things are addressed in programming questions. Something which is not that much conceptually, it's just tested in objective questions. So better be prepared with this. But as you know, the thesis exam is going to be totally objective question.
Got it.
There will be a programming exam at the end. I mean, not at the end. It will be, as the time mentioned.
Understood, sir. Thank you, sir.
Yeah,
Sir, the programming exam, will it be conducted only once in the end, or in between we'll get some chance to get used to the format of that
it
test?
will be exactly like your I think mostly it will be look like your Python online prepared exam.
Okay. Thank you, sir. Actually, the main problem I personally faced with while giving the programming exam, that it was the first time, and I didn't get used to the format and the proctoring atmosphere and all. So that's why when I gave it the second time, it was actually a better experience.
Okay. Yeah. One more very important thing, there is not a replit or anything in PDSA. So get used to the, text editor which is provided in the portal. So there won't be any support. Replit may be used in some case, but not surely in exam. Yeah, just wait, hold on a minute. Yeah, so please continue. Yeah, there is no replit, or maybe replit may be used in for live sessions, or so it's totally up to you. Yeah, so there won't be any you don't expect any replit or anything in the exam, programming exam. That's what I'm saying. Better used to the portal ID.
Hello, sir.
Yeah.
Sir, actually, I don't know if I remember correctly or something. I think in the orientation of PDSA, or I don't remember properly if it was PDSA or DBMS, there was some talk about live sessions, which will be like casual competitions of like coding efficiency
Yeah,
and all.
We are trying that for first week. There won't be, I think, there won't be any live session based on the live coding session. We are trying
Yeah,
to
yeah.
implement the live coding sessions.
Yeah, sir. So can you give any more information about
Okay.
Those kind of sessions?
Okay. If you have attended the Pythons in later week, there is one live session which is live coding, which is based on Replit teams. So that is worked on based on Replit teams. You have to go there. There you will have a problem. You have to solve it by yourself. It is not like a regular live session. We'll come and help you. We are not explaining the problem or anything. If you are facing any trouble, we'll come there and come to your editor and we'll comment out what is the mistake you are doing, or like that. You have to, whatever the instructions, right, it will be given before.
Okay, okay.
Yeah.
Thank you, sir. So you mean to say that it is that right now is in the initial stages of planning?
Yeah. But definitely there will be live sessions, live coding sessions that I sure.
Yeah, sir. And sir, do you have any idea of the how frequent those sessions will be in? Like how many can we expect in one term?
I don't know the numbers. At least you can say maybe once every week I will try.
Okay, okay.
Yeah, I'm not sure about the when you are having a quiz or like it's total based on operationally. It's a once every week.
Okay, okay. Yeah, sir. That actually will can make us used to how the proctored programming exam will be to some extent.
Yeah, yeah. Also, don't depend mainly on the Python or whatever the comes up, because in the end in the exam You have to solve by yourself only. There won't be any console. It will be a simply like a computer, simply objective questions only. So then just remember the dates what you did on CT. It will be exactly like CT.
Yeah. Yeah, sir. But actually the scene is like during the quizzes and quiz the because of the two quizzes we get used to the question format of the objective exam, but because the programming exam is conducted just once in the end and it is like proctored with all the proctor audio coming into our ears 24/7 during the test. That's why I was asking ki, for
I
some
mean, already you are used to online proctoring exams, right? So
yeah,
no
now we are
you are
used to it.
comfortable.
But those live sessions will surely help get us familiarized with the climate of the online programming because of the pressure situation that is created during that test environment.
I mean, time it yourself.
Okay.
Yeah, always do that.
Yeah, sir. So can you suggest like some format, like how can we time us, like take some 10 questions or like just take this five graded assignments and then we need to complete that in an hour or something like that.
Okay, I mean, whatever the graded assignments which we are given, right, which is
Yeah.
not based on any exam point of view, because these graded assignment, you have to take some more time. Also, it's the first time you are seeing, so the time will quite vary until you are figuring out the logic. So it will, I mean, we are expecting not giving any particular time for the graded assignments. Some people will take 2 hours for a single question.
Yeah.
So in these graded assignments and practice assignments for weekly assignments, which is not based on, this not designed based on time. When you are going to write a quiz or final exam or a online proctored exam, there the time factor will be considered.
Yeah, sir. But in the programming Python exam, I observed that lots of questions were almost straight from practice and graded assignments only.
Yeah.
So, sir, like in some questions or in discourse, can we expect like?
There is no, I mean, I don't know about the final exam. It's not, I not give any assurance, but you can get similar question. I cannot assure anything. You will get the same question.
No, sir. I'm not asking about the questions. I am asking like, can you suggest us some like almost like a learning path of how we can practice that timing situation? How we can time ourselves?
Okay. Yeah. In that case, I will say practice is the only answer I have, because it depends on every person's, right. I mean, practice is the constant with everyone have.
Yeah, sir. I think even in
Yeah,
this,
one more thing, whenever you are seeing the lecture, just very much aware of that, what is going on. I mean, you are aware, of course, you are aware of that. But what is, Sir will explain some algorithm. After that, Sir will explain another algorithm. What is the difference between those? And when you are getting into, I mean, reading the problem statement, what you have to do? Because most of the things will be implicitly mentioned or not even mentioned. You have to define what is the data structure you have to use, because here you are using I mean, a very efficient code which is required. So whether you have to use a list or a dictionary or a set, I mean, it's totally up to you. Yeah. So very much aware of that. This course is totally based on data structures and algorithm and how to use them both at the same time.
yeah, sir, got it. So from week one lectures, what I have observed is programming with Python in that course we just had to, we were just given a question and just we had to get the output. That was the motive.
Yeah.
But in this one, we actually have to compare between multiple ways to solve one single problem.
The practice in the sense, right? How I would suggest is first write your solution to get the output, then optimize by yourself. Just search for a way that you can optimize your code. Optimization in the sense, the first, I mean, the primary optimization should be, I mean, the asymptotic complexity. Whether if your, I mean, code is taking like a n square, then can it be optimized to n log n like that? I mean, something which is lesser than that with respect to the asymptotic complexity. That is the primary aim of this course.
Okay, yeah, sir. So actually, I haven't seen the week 2 lectures, so I don't understand the asymptote thing. But
simply, don't in a simpler sense.
I think I can understand that it can be something which we are initially doing using 2 loops. If we can do just using 1 loop.
No, it's not like that. Let's say in a simpler sense, what is the worst case? I mean, what is the worst case in which you take the more time? Let's say you are searching in a list. Okay, if you are going through, you have a standard process. You'll go by element by one from first to last. Let's say you have to find a. I said some element. I am asking you whether find it and whether it is present or not. Okay, then what is the worst case? How many elements you have to test for an element which is not present in the list? Let's suppose there are 100 elements.
Okay. So it's you are saying like it's like the example of what sir said about the halving strategy.
Yeah.
Okay. So and that takes 10 power 9 into 30 as compared to 10 power 18.
Yeah, that's a SAS example. Yeah. I'm asking just a question. I'm not don't go much about it. There is a list. There are 100 elements. Okay, and then I asked, let's say 100 distinct number is there.
Sir, can you like draw on that
sure.
Your screen?
Like that, there is a list. Okay, some 100 elements is there. I want you to find an element. Let's say 7.
Yeah, okay.
Whether 7 is present in L or not, present in the list or not. How many elements you have to go through?
Okay, so we will imagine the worst situation like 7 is the second last element.
Okay, yeah, okay. One more way. 7 is not present in the list.
Okay, so we'll have to go through the whole list.
Yes, absolutely. That is the much worst case. What you said is it is the last case. That last element. That's a valid point. But both are the worst case.
Okay. So, sir, so what do you suggest to make the situation better? So the halving strategy will make us go quicker, or
okay. Let's say I have a list which is arranged in some random order.
Okay.
Will you be say that the halving strategy will work?
No, sir, because we assume the list is sorted.
Yeah,
in that situation.
So in that case, we need a sorted order.
Okay.
So first sort the list, then do the halving strategy. I mean, if it's a sorted list, that's better. But in some scenarios, you need a sorted data structure, sorted list like that. But in some case, it is not required.
Okay.
You will get to know it later.
BST can also be used, no? Binary search tree.
Yeah, I mean, yeah, that will be introduced in later weeks.
Right.
Yeah. I mean,
So what would you suggest if like here we have a list of numbers, right?
yeah,
If we have a list of let's say strings, then what would you suggest one person should do to find element is there or not in the list? Here we can sort it because it's all numbers, but what if it's all strings then?
strings. I mean, actually, I'm not even aware of the exact answer. What I just my answer will be like you can use the same Python string comparison. That one way. Just I am getting to that. I don't have any standard answer for that as well.
Okay.
But generally, whenever you say sorting, right, mostly numbers will be involved. But if you are searching someone's name, then what you're saying is false.
Correct, correct. So like we have a list of students and we just want to find if the student name is there or not. So
Yeah. Yeah, that's why most of the time you will be assigned with a unique ID. I mean, one clever strategy is just practically I'm saying you are enrolled in some organization or some group, you will have some ID. That ID will provide a random access. Instead of going through your name, there will be a list of names with something like that. Person doesn't want to go through all the names. Okay. So instead of that, you will be given some ID.
correct.
Then that ID will be mapped into your data.
Like
So,
a dictionary.
yeah, and at least in the like a dictionary, or in the worst case in a practically scenario, that ID was the data was assigned sorted based on your ID.
What?
Insert, yeah, it arranged based on your IDs.
Okay, okay.
Yeah. Yeah, always make sure you can compare with the real life scenarios. That's what we are going to apply this.
Yes, yes, yes. That's how we come to know what is the application of the subject in the real life.
Yeah.
And this is a subject that is asked very much in interviews. So
yeah,
very important to do this.
anything else? Anyone?
Sir, I just have one last administration doubt.
Yeah.
I see that the week 2 content is already released on the portal as well.
Yeah,
So,
I mean, week 2 lectures and objective assignments are available, I think.
yes, yes. So, is this going to be now there every week? Like on this day, it's going to be released, or is it just
Oh,
because?
no, the first 2 was like that.
Okay, okay, okay.
Yeah, whatever you have informed, right? Thereafter, it will be released on that day only.
Okay, okay. Generally, it's released on the Friday
Yeah.
of every week.
Yeah. It is just like heads up for you to go through the 2 weeks condensed in the first year. That's it. Okay. If there is no more doubts, we can wind up the session as well. Okay. Anything else?
Actually,
Okay.
so most of us have not yet seen all the
Yeah,
lectures.
yeah, I agree. Yeah. Yeah,
If possible, try to in the next time give us some space.
yeah, I definitely, yeah. We'll know, I mean, the live session after the graded assignment ends.
Okay, okay.
Okay. We'll close the session. Bye. Bye, everyone. Good night.